Welcome, and in this lesson, we're going to talk about compute and networking services that are required for the AWS Certified Solutions Architect Associate level. Now, AWS provides a robust offering of compute and networking services. These services have different use cases depending on your application type, build, and deployment method. In this course and for the certification, we will focus on the following compute and networking services. Elastic Compute Cloud. We will be focusing on this quite a bit. We'll be doing a lot of hands-on concepts. We'll be looking at the auto-scaling service. We'll be looking at and using the auto-scaling service, the Elastic Load Balancer to load balance traffic among our instances and across availability zones, and Elastic Block Store Volumes, which are network-attached block storage devices. We'll also be learning how to use the virtual private cloud, build our own virtual private cloud. We're going to learn a lot of the core concepts as it relates to virtual private cloud, which is our own isolated environment of cloud resources. And Amazon Route 53, we're also going to be using this quite a bit. Now, Amazon Route 53 allows us to host domain names and manage internal and external DNS. Amazon Elastic Compute Cloud provides scalable virtual servers in the cloud. The virtual servers can run different operating systems, but most commonly run a flavor of Linux or Windows. In this course, when we need to use Amazon EC2, we will be focusing on the Linux distribution. An EC2 virtual server is known as an instance. It can be made up of different instance types and sizes, and these will be important to understand when it comes to architecting applications. Instance sizes and types refer to the amount of virtual compute cores or processors, the amount of memory, the amount of network throughput, the amount of EBS throughput that's allowed for a specific instance. When it comes to designing highly available fault-tolerant systems, we no longer just build one server. We have multiple servers that serve traffic among those applications, using a load balancer, for example. So designing the proper instance type to keep the proper balance between number of instances and load for highly available and fault-tolerant environments will be very important. So when it comes to Amazon EC2 instances, there's specific pricing models. As we know with AWS, you pay only for what you use. So for EC2 instances, we have reserved instances. You can purchase reserved instances based off the amount of usage you know you will be using for an instance. So for example, if we know that 100% of the time, our auto-scaling application and working with Elastic Load Balancer is always going to run a minimum of 2 web servers, 100% of the time, 24/7, then what we want to do is we want to purchase down our cost. If we know we're going to be using those 2 web servers, we want to purchase a reserved instance. A reserved instance guarantees that we will have access to that AWS resource in that specific availability zone. Now, that does imply that there could be times when there are no available instance types within an availability zone, and that is very rare and uncommon, but is something that we have to consider because it does happen on AWS. So if we know we're going to be using at least 2, we'll purchase 2 reserved instances for 100% usage. If we know that our auto-scaling application will scale up another 2 instances, maybe 50% of the time, we can purchase a reserved instance for half capacity. And what happens when we reserve these instances is not only does it reserve it for us inside the availability zone, but it reduces those costs of hourly usage. So the amount we pay per hour goes down. And on-demand instances are used on demand. They're paid for by the hour. It means you spin them up when you need them and you spin them down when you don't need them. And spot instances. Spot instances allow us to bid on unused EC2 instance capacity for a lower cost. We can bid on unused capacity to run batch processing applications that are not time dependent or production dependent. The reason it needs to be non-production applications or applications that if they're shut down affect our environment negatively or our job or our users is because if AWS needs those instances that you've bid for on capacity, it will shut down those instances and take that back from you. So you can only use it when there is unused EC2 instances or capacity. And again, that is for non-production applications or applications that can have service interruptions. Autoscaling is one of the coolest Amazon Elastic Compute Cloud features. Autoscaling is a service and method provided by AWS in order to increase the number of instances on demand based on certain metrics. If your application demand increases unexpectedly, then autoscaling can scale up to meet the demand and then stop instances as soon as demand decreases. This is also known and is a perfect example of elasticity in an AWS environment. The Elastic Load Balancer provides load balancing and is a common method for distributing traffic evenly among servers. You can think of it as round-robin load balancing, which means unless we enable sticky sessions, which we'll take a look at, it'll evenly distribute traffic that comes from Route 53 domain alias to the Elastic Load Balancer. So say that you have 4 web servers that belong to an Elastic Load Balancer, 2 in one availability zone and then 2 in another availability zone. Well, what will happen is the load balancer will evenly distribute to among the traffic among the 4 instances based off traffic that comes in. So it'll come into Elastic Load Balancer, go to one instance. The next request will go to another instance. The next request will go to another, so on and so forth. And it will evenly distribute that traffic among those instances, which means if one of those instances becomes unavailable, then the traffic will go to the other instances. And because it's inside of multiple availability zones, if one of those availability zones becomes unavailable, the traffic will go to the other instances. So if we lose 2 of our instances and 2 of our instances have increased load on them, our autoscaling application should see that there's an increased demand for those instances or that the instances are unhealthy, and will automatically fire up new instances to accommodate for that loss in demand. That's fault tolerance, that's high availability, that's scalability, and that's elasticity all in one. Very cool service. Don't worry if it's overwhelming. This is just introduction. We're going to work on all of this hands-on. So Route 53 is a domain management service by Amazon Web Services. Route 53 will host the internal and external DNS for your application environment and is commonly used when directing Elastic Load Balancer traffic or CloudFront traffic from the domain to the Elastic Load Balancer. Now, you can also now register and transfer your domains from a domain registrar to Amazon Web Services. An AMI is what's referred to as Amazon Machine Image. It's a template that contains pre-built software configuration. Amazon Machine Images are used when using autoscaling and disaster recovery. If you're coming from a VMware world, you might think of them as VDKs. They're images that have pre-built software installed on them that we can just fire up with a pre-built configuration. Now, there's different types of AMI storage types. We have what's called an instant store back instance. And anytime we fire up an EC2 instance, it's being fired up from an Amazon AMI. So an instant store back instance has what's called ephemeral storage. It's temporary storage. It's block level temporary storage over the life of an instance. So what this means is for as long as your instance is not turned off or not shut down, that temporary storage data will still live. You can reboot it and it will still be there. Important concepts, by the way. Please take note. We'll talk about this many, many times throughout this course. But if you turn off your instance, that temporary storage will be lost. EBS backed instance, or it's called Elastic Block Store. Elastic Block Store is a network-attached block storage device, which means you can attach it to your EC2 instance. It's attached over the network through network cables, Cat5 cables. It's a network-attached connection. It's not a direct attached connection. It's easy to back up with what's called snapshots, and these snapshots are stored on Amazon S3. These snapshots are point-in-time snapshots, which we'll also spend a lot of time on. You can provision additional input IOPS, which is input output, increases the amount of input output we have. If you have a lot of writing and reading from the Elastic Block Store device, we can increase the amount of provisioned IOPS. We can also use EBS optimized instances to help network traffic between the instance and EBS volume. It basically prioritizes the traffic from the EC2 or EBS optimized instance from the Elastic Block Store. Elastic Block Store volumes can be as small as 1 gigabyte, which is 1,024 megabytes, and as large as 16,384 gigabytes, or 16 tebibytes in size. EBS volumes cannot be attached to instances in a different availability zone than the EBS volume is located in. So your EBS volume needs to live in the same availability zone as the EC2 instance you want to attach to it. And we're going to talk about how we can move Elastic Block Store EBS volumes from one availability zone to another. We're going to talk about building and designing these applications. This is just to get you understanding and an introduction of the required services. An EBS volume can only be attached to one instance at a time. An EBS volume has point-in-time snapshots. So a few basic security considerations to get our feet wet. It's up to the customer to manage the software level for security on instances. So for example, security groups that are assigned to our EC2 instances to allow traffic in and out from specific source locations or ports. Local software-based firewalls on your EC2 instance. For example, in Linux, we'll probably use IP tables or Firewall D. EBS encryption provided by Amazon Web Services. That means we can encrypt an EBS volume. We can also encrypt the snapshots from EBS volumes. EBS encryption on AWS utilizes the AWS Key Management Service. An additional encryption can be to encrypt the entire file system using an encrypted file system. Now, this is a potential. We might use the EBS encrypted option, or we might use the encrypted file system option. Now, EBS encryption is only available on larger instance types and is suggested to be used on larger instance types. Any instance type smaller than an M3, so an M3 can use EBS encryption. Any instance type smaller than an M3 should not use EBS encryption because the amount of resources required in order to perform the encryption. Anything lesser, you can use an encrypted file system from Linux. It's still going to use a lot of resources, but it's an option to use an actual Linux or Windows encrypted file system. When it comes to using an SSL certificate for our web application, since we're going to be designing high availability and having multiple servers, we don't want to assign the SSL certificate to a specific EC2 instance if we're serving a web application. We can actually assign it to an Elastic Load Balancer, so it will apply to all of our instances. AWS will manage the hypervisor and physical layer of security for Amazon EC2. It'll provide DDoS protection, port scanning protection, which also means that you cannot, please note, you cannot perform port scanning within your own AWS environment. This means you cannot port scan two instances inside of your own virtual private cloud unless you specifically request permission from Amazon Web Services. And ingress network filtering. Amazon ensures that the traffic coming into its network is coming from the stated resource that the packet says it's coming from. Virtual private cloud is one of the core components of Amazon Web Services. And really, nowadays, no application that utilizes EC2 or RDS should be designed without it. VPC allows for the isolation of AWS resources in the cloud. Resources fired up in a single VPC will be part of the same network and can communicate internally. This means that two EC2 instances that belong to the same virtual private cloud can communicate internally without leaving the virtual private cloud using their internal IP addresses. However, if multiple virtual private clouds are used to provision resources, then resources in one VPC are completely isolated from the other VPC by default. Resource sharing between VPCs in the same region can be allowed with VPC peering, but is not covered as part of this course or certification. VPC does not cost. Only the resources within the VPC have costs. So for example, creating a VPC does not cost. Firing up EC2 instances within a VPC is the only cost you will have. You will have standard EC2 instance costs. You have the option for network layer security with access control lists. You can filter at the subnet level. You can use elastic network interfaces, attaching multiple elastic network interfaces. You have the ability to use an internal elastic load balancer, which can allow us to design multi-layer applications. And of course, we can use VPN to create VPN dedicated connections or regular connections between our on-premise data networks and our AWS cloud resources. Now, a little bit about EC2 Classic. EC2 Classic is a deprecated service by AWS. Some accounts that have been around for long periods of time are still using the service. However, EC2 Classic instances do not belong to a VPC, and EC2 Classic does not utilize a VPC, which can be a little bit of a security issue and have specific limitations. We'll talk about those limitations later in this course. However, if your account was created after December 2013, then EC2 Classic is not part of your account. And again, in this course, we will have a lesson dedicated to EC2 Classic concepts, especially if you're working at a cloud consulting firm or working at a firm who goes in and helps customers with their AWS resources. You might encounter resources that are still utilizing EC2 Classic. Route 53 is a DNS hosting solution provided by Amazon Web Services. You can not only host the DNS for domains, but can now also register and transfer domains to AWS. Route 53 manages external DNS for domain routing. For example, www.domain.com will be sent to the proper AWS resources as defined within its CNAME, or whatever alias record set is defined inside of Route 53. Route 53 can be used to manage internal DNS host names within a VPC as long as a VPC is configured for it. So this now means we can define a host name for a specific instance. If we have an NFS server, we can set up nfsserver.internal.domain by using Route 53, and this is a new feature. With Route 53, we can configure latency, geographic, basic, and failover routing policies that allow for region-to-region fault-tolerant and architecture design. You can set up a failover to an Amazon S3 bucket or CloudFront distribution if website bucket hosting is enabled for S3. That's a neat feature, and we will take a look at that. So in other words, if for some reason your highly available web server application still can't handle the load, or something happens, Route 53 can fail over to serving just a static "will be back soon" HTML page inside of an S3 bucket. So let's take a look at this diagram from AWS. It's really an architecture of all of the resources that we've talked about within this course. So for example, this is our AWS cloud. We have our users, Route 53, Internet Gateway. An Internet Gateway needs to be attached to a VPC subnet in order for there to be a route from your private, isolated, VPC-based resources to the open internet. So a user might go to www.domain.com. Route 53 will route them to our AWS account. This is our VPC. Within there, we hit our Internet Gateway. Our Internet Gateway communicates with the Elastic Load Balancer. The Elastic Load Balancer will use round-robin DNS, and it will send the traffic to instances appropriately. So we have two instances that are serving the same application. However, if you look here, we have Availability Zone A and Availability Zone B. They're in different availability zones. So what happens if Availability Zone A becomes unavailable? Then the load balancer will automatically remove this unhealthy EC2 instance, and it will only serve traffic to the EC2 instance within this availability zone. However, our auto-scaling group should be able to detect that our application has become unhealthy. Thus, it will fire up another EC2 instance in a healthy availability zone, which will make sure that our application is self-healing and can handle the load. All of these things we're going to learn within this course. So I hope you have a little understanding and basic overview about what we're going to be learning and about some of the compute and networking services that we're going to be learning about. Everything that we talked about, we're going to cover more in depth, so don't worry if you are a little overwhelmed. We will cover this, and you will be a prepared and qualified certified solutions architect. Go ahead and complete this lesson.